Hi and welcome back. This is Module 9, Storage Area Networks. In this module we'll be talking about creating LUNs, mapping LUNs, and from a client perspective, using LUNs. Now this is not to insult you, but I thought it might be a good idea to just have a quick overview of the major differences between NAS and SAN. When we talk about NAS environment, as we've seen in a previous module, your client will map a drive or your client will mount a file system which is managed by a storage virtual machine at the other end. So in this case, your client is only able to create files, copy files, remove files, and whatever a client would want to do to files. But the client is in no way responsible for the file system itself and has no administrative power over that file system. So that means if at the Netapp level you decide to grow the volume, for example, then the client will see that all of a sudden he has more space to create files. This is obviously why it's called file level access. So the client can access files. In the SAN environment, however, this situation is totally different. Your storage virtual machine will have a volume, and the volume will have a single file, and that file will be mapped to a client. Then the client administrator will be able to create a partition on the device, which is treated as a local disk, and that partition can hold a file system of any sort. So in the end, you will have file system management at both sides. On the one hand, you'll have your target, which is your storage virtual machine, and that storage virtual machine will have a volume which is managed by Netapp, obviously. And at the client side, we will have a device that will be partitioned and also holds a file system. So that's file system on top of file system. And now the client will have administrative control over his own file system in which he can put files. To the Netapp environment, these files are transparent. So to Netapp, it is just a single file, and the file has blocks. So the major difference is the administrative power that a client has over a file system or not. So in summary, a LUN is a file in a waffle volume. The LUN is mapped to the client. The client has block level access, can manage the device, and for example create a file system. So the supported SAN protocols in ONTAP are 5-channel protocol, for which you need a separate 5-channel network with SAN switches, which completely separates all storage traffic from the regular network traffic. The second one is 5-channel over Ethernet, and as you can see, what you in fact do is you have a separate protocol, 5-channel over Ethernet, which replaces the TCP/IP stack. So you do not need TCP/IP, but you still run Ethernet. And finally, we've got iSCSI, which is a SAN protocol on TCP/IP. And we have two types of clients. We've got 5-channel clients and we have iSCSI clients. And the client in either case is called an initiator. And obviously the SVM that receives the client's data and the SVM that holds the LUN is the target. And when you run iSCSI, the client will have an IQN name and the SVM will also have an IQN name. So there will be an initiator and there will be a target IQN. And in all cases, the client will have to log in to the storage virtual machine. When you run fiber channel protocol, either 5-channel over Ethernet or regular 5-channel protocol, then you will have worldwide port names via which the client can log in to the SVM target. Very important to remark is that a SAN LIF, we've already discussed that, but again, a SAN LIF does not fail over. You can migrate a SAN LIF to a different port, but then the LIF will have to be taken offline. So this is not something that you should really take into account. At least it's not automatic. You cannot fail over your SAN LIFs. So this is also why you cannot combine the NAS protocols and SAN protocols on the same LIF. So it's either an iSCSI or 5-channel LIF
or it is a NAS lift, so NFS or CIFS. So the best practice that Netapp advises is that you have a minimum of 1 lift per node per network. Now let's have a look at iGroups. The iGroup, or initiator group, is in fact the hub of the entire SAN environment in the storage virtual machine. What you do is, after the initiator has logged in, the LUN that is mapped to the iGroup will be a device on the client because of the fact that the initiator is in the iGroup. So you create an iGroup, then you fill the iGroup with one or more initiators, and then you will map the LUN to the iGroup. Optionally, you can connect a port set to the iGroup. The reason why you would want to do that is that if you have multiple lifts connected to an SVM, then all of these lifts could be accessed by a client to get to the LUN. To avoid that and just specify particular lifts to be allowed to be used by clients, what you do is you fill a port set with lifts, and then you bind the port set to the iGroup. So the steps are: the iGroup will have to hold one or more IQNs, or worldwide port names, and the iGroup supports both ISCSI or Fiber Channel. You also have to specify an operating system type when you create the iGroup, and then you map the LUN to the iGroup. The client will rescan for new devices, and then the client can manage the device.